Look at a modern AI model, and it is easy to feel overwhelmed. We're talking about billions of parameters, a massive, intricate web of connections. But when you first turn that massive structure on, it is effectively hollow. Every single one of those billions of connections is set to a completely random value. You cannot pre-program intelligence into a system this large. Because the initial state is a total blank slate, any functional output must be constructed through an iterative process of learning. To see how that learning actually works, let's look at a simple prediction. Say you feed a house's square footage into a computer to predict the final market price. The mathematical bridge between these numbers is a weight. Think of it as a dial on the connection, actively multiplying the data to spit out a price prediction. If you only have one single dial, you can easily turn it yourself until the math works out. But a modern neural network has billions of these dials. Tuning them by hand would take lifetimes. To solve a billion-dial problem, the machine has to be allowed to make a terrible first guess and figure out how to correct itself automatically. During what we call the forward pass, we feed our housing data into this untrained network. The data flows forward, passing through all those randomized dials, and naturally spits out a wildly incorrect price. This bar chart shows exactly how we handle that failure. We take the network's bad prediction and compare it against the actual true price. The massive gap you see here is calculated by the cost function, a mathematical measuring stick used to determine the exact distance between the bad guess and reality. An AI does not actually want to be smart. Its sole mechanical objective is to take that cost function value and shrink it down to zero. We can visualize all of those potential errors using a 3D topographical landscape graph. In this space, height equals error. Because our network just made a terrible guess, its marker is currently standing high up on a steep slope. To figure out how to get off that peak, the network uses an optimization algorithm called gradient descent. It reads the terrain by calculating the exact angle of the curve directly beneath its feet. By reading that slope, the algorithm knows precisely which direction is down, toward a lower error rate. Finding the very bottom of this mathematical valley represents the point of optimal accuracy for the model. Knowing the general direction of down is helpful, but it doesn't solve the logistical problem. The network still has to actually turn its billions of individual dials to move there. To do that, it uses backpropagation. Think of it as a reverse electrical signal carrying the error data backward through the architecture. The reverse signal hits the final output layer first, assessing these nodes to find the immediate mathematical errors that ruin the prediction. The signal propagates deeper into the hidden layers, calculating how each internal connection contributed to the final error. Once identified, the network executes a penalty phase, mathematically weakening the exact weights that amplified the wrong answer. At the exact same time, it strengthens the specific weights that pushed the calculation toward a more accurate trajectory. Backpropagation is the mechanism of learning, translating calculus into billions of precise, simultaneous adjustments to the network's parameters. A single cycle of adjustment makes a mathematically microscopic difference. Even after the forward guess and the backward adjustment, the network is still effectively useless. Real predictive power requires an epoch. This is the relentless repetition of the forward pass, error calculation, and backward adjustment playing out thousands of times. The accumulation of these millions of micro-adjustments eventually pulls the network all the way to the very bottom of the gradient valley. The result is the illusion of instant intelligence, which is just the result of this optimization loop running at a scale beyond human comprehension. Popular culture treats artificial intelligence like a conscious black box, but the reality is far more industrial. It is a calculus-driven engine. Machine learning is ultimately the result of a machine navigating a landscape of its own mistakes to optimize its parameters.